All right. Well, let's present.
Get the recording going. All right. Welcome to today's virtual users group. We've got Shlomi Abraham from Seagate presenting to us today, and I am going to turn that over to you. I've posted the link to the website. You can download the slides from there for anybody that wants a copy. And any questions that come up, put them into the chat window, and I'll relay them to Shlomi. Shlomi, I'll turn it over to you.
Great. Thanks very much, Kevin, and thanks everybody else for joining us. With today's topic, we're going to cover the S2200 and S3200. Some people call it technical training. Some people will call it technical sales training. There's some deep dives in it. There's some screenshots and UI in the presentation. And the main goal for this is basically to give you a good overview of what the S-series arrays can do today, where they stack up versus the competition, some of the key benefits, advantages, and some disadvantages as well. And basically get this conversation going as to what do we really have here at our hands. It's a lot better than what we actually think, or a lot better than what our sellers and partners actually think. So it's really important for us to try and get that message out and get more and more education going on this product. With that, I'm going to go ahead and let me start with the agenda. So what we're going to do today, we're going to talk about the hybrid arrays overview. It's basically an overview of what the market currently does, why it does it, where is the industry going from and to. And we'll talk about the 22 and 3200s overview, what each one of these products could do. Hardware deep dive, software deep dive. I've actually cut the deep dives so it's not too deep, but it still has some key information in it. Then we got the software UI, and then some targeted workloads and use cases. Let's talk about some market trends. So Lenovo hybrid arrays are positioned in a growth market. If we look at these numbers that we're seeing here in these graphs, what we can basically see is the capacity growth and the revenue growth within the storage industry. Well, everybody knows today that our smartphones, our laptops, our computers, our servers, everything requires a little bit more capacity. I wouldn't say a little bit, I would say actually even more than a little bit. I joined the storage industry in about 1998, and I'm still amazed to see how much the industry has changed, how much more data we consume, how much more capacity we require, and it makes such a huge, huge difference. Now, a few things that I like to talk about in this slide, which are really, really critical, is the use of hybrid arrays. What exactly are hybrid arrays? So everybody knows the old-fashioned spinning drives, which are the mainstream disks. Now, everybody's been talking about flash arrays as well. So these are the SSDs that we're talking about, some NAND, some different forms of factors for smaller capacity but faster performing storage means. Now, the industry says, well, why do we even need that? And when I talk to a lot of people, I keep telling them, if you look at what we do on a daily basis, so we use phones, smartphones, we use laptops, we use computers, and if we think about the items that we use in our personal life, or the things that we touch almost on an immediate basis, all these items, if you think about it, they're all actually using flash. So if you look at your cell phone devices, your entertainment devices, your iPads, your ThinkPads, they usually all have some sort of a flash mechanism to accommodate the performance for speed. And that's one thing that I keep telling everybody. We get used to something. It's called the microwave of storage era. So basically, we're used to clicking something and seeing it right away, clicking on a map and getting direction right away. We've become impatient to wait for data to actually pile up or get together and brought to us. That's usually in the day-to-day activities, and that actually translates as well into the data center and the application and the business units. So people want to click something and they want to get the report right away. People want to do something and they're not used to back in 10 years ago where you click on a report, you go have a cup of coffee, you come back, and then you're actually able to see the data. So these things are actually driving the needs within the storage. So with that, ideally, everybody would want to buy, all SSD arrays or all flash arrays. In theory, it's true. The only big problem about this is capacity and cost. It's a big, big difference between the spinning drives and the SSDs or flash. Now, it is true that flash drives prices have been going down, but they're still significantly higher. And if I look at these next screens, so flash is about 10x more expensive than disk. It's true per capacity basis. Disk is about 10x more expensive than flash. That is true on an IOPS basis. And then economics of hybrid and disk flash architecture, and that basically is what we're trying to offer here, and that's where the market is basically moving, is the best of both worlds. You'll have some spinning drives, and your unhot or unimmediate attention-needed data will be stored there, and then anything that will be hot and will require that fast, immediate, click and get kind of a thing could live on the SSD. Now, this is all great, but how do you actually make use of it? Well, there's different methods about it, and I'll talk about batched migration, and I'll talk about real-time migration. But basically, it means that you want your hot data, you want your critical data that's hot at any given time at a fast-performing disk or at a fast-performing capacity, meaning most likely on your SSDs. You don't want your hot data to be on spinning drives. And then how do we do that? We'll get to that in a few more slides. Business values for hybrid arrays. Well, it's about 70% lower cost. So if you take an S3200 and you pop it up with SSDs and spinning drive, and you take the equivalent same capacity within flash arrays, it's going to be about 70% lower. Sometimes I've seen even more significant cost. It eliminates silos of flash. So other people have come to me and said, well, I can get a flash array for my Exchange, or a flash array for my VM, some flash here, some flash there. It is true. But because not your entire SAN is made out of flash, it actually creates these silos, and they're hard to manage, hard to maintain, hard to control, and also hard to grow. So that's why I think it's another big thing. Automatically discover random versus sequential workload, and that's the amazing piece about this, is from the user's perspective on anything on the S-series array, the user's got to do nothing with determining what's hot and what's cold. Is it random? Is it sequential? The system itself will be able to automatically identify the workloads, the block sizes, what day of the week, which user, which server, and then be able to make sure that if the system believes that this is hot data, and it does that in an intelligent way, but it basically looks at something that we call a report card. And I'll get into it in a few more slides, but it basically talks about how we evaluate the data. And we have a scorecard for each page. A page is 4 meg in size. And what we do with these is we actually look at them and say, well, you know what? This page has been accessed every Tuesday in the morning. It's random. It's small block size. So we're going to say it's hot data. It's something critical. It's something that's important. And then on the other side, we have either a backup area, or we have an FTP site, or we have a video surveillance area where we just dump data into. So the system will identify that as sequential. Sequential doesn't gain as much performance from SSDs anyways. And then it's something that doesn't get touched often, so the system will automatically trickle it down and have it parked in either 10K drives or 72K RPM drives. That's basically where this whole thing comes about. Near zero time and labor spent in performance analysis and engineering, so you don't really have to understand, wait a minute, this VM, does it need to be on SSDs or not? This host, this volume, does it need to be on SSD or doesn't? The system will be able to accommodate that for you, and it will, on the fly, keep doing that all the time and evaluate each page of data. And again, a page of data is about 4 meg in size, to determine where do we want to park this page. Is this page considered hot? Is this page considered cold? And by that, we'll be able to make that. High capacity without sacrificing performance. So you can gain capacity for your videos, for your FTPs, for your home shares, for anything that doesn't need the performance in the same array with the same management. And you don't have to say this volume goes to here or that volume goes to there. The system will automatically, discover that and identify that. And that way you can get some of the SSDs, and you can at the same time get more of the capacity for the spinning drives and get a large data set for you on your SAN. We're not going to have time to do a live demonstration on this session, and I'll work with Kevin, and perhaps we might add one. But I have a great live presentation that I show, or live demo that I show, where I show you a system running with 10K drives, and I run an IO meter workload on it. And when I run that workload, we get an X amount of IOPS and an X amount of throughput and an X amount of latency. And what I do is I just go out and add 2 more SSDs. So I take 2 physical SSDs, stick them in the array live, and then what I actually do is show how the system automatically starts to move the hot data into the SSDs. And all of a sudden, that workload that we just had, which was running an X amount of IOPS, it's running about 20X of IOPS. So we actually go from about 1,000 IOPS to about 24 or 23,000 IOPS. And the latencies where we were at about, I think it was sub 30 milliseconds, and all of a sudden you're sub 1 milliseconds by just adding 2 SSDs. And we'll talk about this a little bit more further down the road. We'll also talk about the SSDs today and with the reducing price of some of the cheaper SSDs. When I say cheaper or more cost-efficient SSDs, we now with Lenovo offer the 3 drive writes per day SSDs. It basically means it's an SSD that will be able to write to any section of its flash about 3 times a day. And we found out that the way we utilize our system and the way we utilize our automatic tiering, we'll be able to still accommodate these drives with the basic 3-year warranty for them. And I think there's even an extension option to add it to 5. So it's still a great value to take 2 SSDs at about, I'm going to throw a number out there, a $500 mark or $600 mark, maybe even a $1,000 mark. But you take 2 of these, it's about $2,000. You add it to a system, and you're able to get 20x your performance and reduce your latencies by almost 30x. It's pretty significant. So these are important points that we'll touch again, and we'll move into it. I'm going to pause here for a second. Kevin, I just want to make sure you can hear me well. Everything is fine. You can see the screen, and if there's any questions so far.
We can see the screen very well. I have one question that just came up. What size SSDs are you using for adding to the design?
Well, we could use anything that's on our compatibility matrix. I don't have a compatibility matrix, but I could probably work with you, Kevin, and we'll get a link and we'll share it to the audience. Any SSD that's on the Lenovo certification website, you'd be able to use. I think they go down, they range from 400 gig all the way to 1 point something terabytes. So you can get to choose and pick which SSDs you'd like. That is on the support matrix, of course.
That's the only question we've had.
Perfect. Thank you. I'll pause here and there to try and get these going, and that way I can get some air as well. Next slide. Next slide talks about the S2200 technical overview. So what is the S2200? Well, it comes in 2 form factors as of today for now. It's a 2U12 or a 2U24. It scales up to 96 drives. And then you can scale up to 3 storage enclosures underneath it. So you basically are able to add 3 chassis underneath it for a total of 4. Choice of interfaces per system, you can get 4 8-gig fiber or 4 1-gig iSCSI or a 4 6 or 12-gig SAS connectivity. So you should be able to get either one of these. Performance highlights, we can get about 80,000 IOPS max reads. For that configuration, if we're looking for a realistic workload number, this system can probably accommodate about 60,000 IOPS. The 80,000 IOPS are small block size and they're read-only, which is usually not always the case. But that's why I like to say these are the measured numbers for 100% read with 4K block sizes. It's 3,300 megabytes per second on read. They could do about 2,400 megabytes per write, which is pretty strong for the price point that a 2200 comes into. And I'm not going to talk about pricing. These are items that I'm sure Kevin and the rest of the team can actually get us. But I'm going to stay away from the pricing. But it's a very appealing, very cost-efficient box, so it's really important to mention. Unique technology, real-time storage tiering. We'll talk about that. The batch migration versus real-time is what we do, and it's quite unique in the way we do it. Battery-free cache protection, and then low-latency cache mirroring, which helps us do a lot of the things that we actually do. And we'll get to that. I'll talk about why do the competitors, and we'll talk about EMCs, IBMs, NetApps, and many more. Why don't they do that real-time? Why do they have batch migration? And we'll talk about that, but it basically talks about the design architecture that we have within these controllers. 2200 highlights, large form factor or small form factor models. You can get that with 7, 10, or 15K and SSDs, so you can still get to use the SSDs in the 2200. They're all active array controllers. It's 2 port per controller. That's the configuration option that you've got. They're flexible interfaces. They're all CNC chipsets. It's actually SFP plus. So you could actually pull out an SFP of 1 gig a year down the road and say, you know what, now I've just upgraded my infrastructure to 10 gig. So you can have your customer pull out the 1 gigs, order just SFP pluses, and then get these SFP pluses plugged back in, and all of a sudden he's got a 10 gig system. So it's really nice to see how simple it would be to actually change and make some modification to this. It's really nice. It really helps the customers with long-term planning. Customers that I might visit might say, well, you know what, I'm only 1 gig today, but I might be 10, a year down the road. It's pretty simple. You don't have to do a forklift upgrade. You don't have to change the controller. All you got to do is purchase 10 gig SFPs from us, and then once you do, you just swap the SFPs, and you're back live. The system doesn't have to go down, and it's a pretty significant option to have. Easy setup user interface, standard and encrypted drive support, so we support encrypted drives. And then hybrid configuration to support SSD plus SAS nearline and SAS. I'll move on to the next slide. The next slide talks about the 3200. So by look, by design, by feature, it's basically the same box. It's got a little bit more power to it. So when we look at the power, it's the same form factor. You can put more drives into it. So you could actually scale 7 more chassis underneath it for a total of 8 total chassis. You get a little bit more flexibility in terms of choice because you have 4 ports per controller. So you could do 8 or 16 gig fiber, 8 1 gig or 10 gig iSCSI, and you could do 8 4 or 6 gig SAS, or you could do hybrid for 4 iSCSI and 4 fiber channels. So if you decide you want to do a hybrid configuration on the connectivity to the array, you get a chance to do that as well. Performance. The other one came out at about 80,000 IOPS. This one can stretch out to 120. It's not that big of a difference when you think about 80 and 120, but this thing's got a little bit more options to do that. So if you look at the megabits per second for reads and writes, it's a pretty significant improvement, almost double of what it could do. The same goes for the amount. So we said it's about 60,000 for real case scenario. If you're looking reads and writes, if you look at this system will probably deliver at about 109,000, 110,000 IOPS. It's a pretty significant amount of IOPS if you think about it. And I haven't seen many small to mid-range customers needing to use more than these amount of IOPS. These are significant boxes. I don't like to talk about future, but there will be an announcement made towards later in the year, towards the end of the year, of another S product within that portfolio, which will be able to stretch and give you close to 500,000, close to 400,000 IOPS. But again, let's put that aside. It's not in the tray. It's not available at this point. But there will be another product that will come in, and when these items will come in, you'll have a very low-end version for about 80,000 IOPS. You'll have a higher-end option for about 120, and you'll have something that's even bigger than that for even more than that. Unique technology, it's basically the same thing. Improved connectivity, performance, and flexibility. So basically, it's an increased bandwidth with 4 ports per controller. The physical connectivity that we talked about, hybrid that we'll be able to do on the physical interfaces. Dual active-active rate controllers for HA. And of course, I don't like to say future-proof for next-generation host interconnect, but the fact that you're able to swap these SFPs or SFP pluses is very, very important. And again, standard and encrypted drives as well.
We have a question.
Sure.
It says, are the IOPS increase due only to being able to add extra drives or also other technology? Hello?
I'm sorry, I had a hard time understanding if the second part of the conversation was an add-on or a clarification for the question, or was it just background noise?
It must have been background noise. Can you hear me now?
Yeah, I can. So, okay, so what was the question again?
Are the IOPS increase due only to being able to add extra drives or also other technology?
Other technology. We'll talk about this 32 and 2200 configuration. It is different. Hardware-wise, it is different within the box. So it's got more power, more RAM. We'll talk about this in a few minutes. 22 versus 3200, you can see the max amount of HDDs. 96 versus 192, SEM form factor for now, max enclosure is 1+3 or 1+7. Single or dual controller for both of them. We don't see many use single controllers, but basically dual is where we want to go. Cache, about 12 gigs, so you can see that cache is the same between the controllers, and I'll talk about the different physicals on the hardware side. I got a nice diagram that shows that. Host connectivity, 2 per controller versus 4 per controller. That's what you gain a lot of your throughput increasement. SSD support and caching, well, you get both of them in the base system, so they're available for both. Intelligent real-time tiering, base HDDs, base HDD on both, and then an optional HDDs plus SSDs. And I'll talk about that in a minute. Our real-time tiering is a free license for spinning drives. So if you have spinning drives such as 7K and 10K, the system by default will let you tier among these two drives. But if you want to gain the performance out of SSDs as well, then there's an optional, it's called performance tiering license, which is not that hefty. If I recall correctly, the MSRP for something like that, it runs about $2,000. So for $2,000, you get to use SSDs and spinning drives within the same one. But we do want to give you a taste of how well the auto tiering works. So base HDDs between 7 and 10K or 7 and 15, you'll be able to get free intelligent real-time tiering, and that's a part of a base license. Snapshotting, 64 base versus 128, optional 256, 512, or 512, 1024. So it basically shows you the difference. Any questions before we move on to the hardware deep dive? And Kevin, I'm not looking at the screen because I got a full screen thing, so I'm relying on you for these.
Yeah, I know. No questions right now.
Perfect. Hardware deep dive. So let's look at a competitor architecture. So let's look at what a competitor controller architecture looks like. So what we've got is you've got the main processor. It's got a memory, which is probably a DDR cache for cache and controller. You got a PCI back-end I/O. That's for the drives themselves. And then you got a PCI front-end, which is usually fiber channel, iSCSI, and SEPs. Then what you have is you have a PCI to the other controller. So highly available systems need to have a channel to talk to their partner controller for high availability. It basically prevents split brains, tell the other controller that every operation that gets done on the other controllers as well. So you basically have everything mirrored. And then the competitors usually also have batteries and NV storage. So let's look at a write command that comes in on a native competitor array. So the write comes in from the front-end I/O. It goes in from the front end, goes into the processor. It's received by the host, and then it goes in through the memory. That's number one. Number two, then after it's written in memory, the processor will come back and say, all right, well, I'm ready for your write data, and it basically tells the host, hey, I'm ready to take the write that you wanted to do. So that's operation number two. Operation number three, the host that wanted to generate the I/O comes back through the front end and through the processor again and into the memory and actually writes the requested I/O that it wanted to write. Number four, the processor's got to do more work again, more heavy lifting again. It basically needs to read the stuff from memory and actually transfer that to the other controller. That's the fourth operation that we'll see that we actually gain on a patent that we have on our controllers, which is unique to our configuration. And that's also why we're able to do more things, and we'll get back to that with the batch migration, but why we're able to do more things versus even the big names within the storage industry. So this number four basically has to create another operation. It takes more cycles from the memory and from the processor to actually take the I/O and then spin it off to the other controller. It's basically mirroring the cache. So it sends it over to the other controller. And then number five, the memory will send it back to the processor and get it back to the host and say, all right, well, your stuff is written into my cache, it's mirrored to the other controller, so we're good to go and your I/O is completed. So there's basically five operations that took place. One more thing that I want to talk about is when a power is lost, there's something that you got to keep active during that time for the competitor controller architecture, and that's why they need more batteries and they got to do more maintenance. What basically must remain active is the processor, the cache, and they're all held by the batteries portion. So you got to make sure you maintain that. So remember these options. Now let's talk about the S22 and S3200. So what we've got a RAID companion processor. This thing basically handles the I/O that comes in from the host. We also have another CPU. It's a CPU complex, and what we do is we put it aside, and we're actually able to utilize that for our software features. So that's, again, a patent that we hold, and we're actually able to do a lot of the processing for automated tiering, real-time tiering, snapshotting, scoring the pages, moving the pages, doing all these items. And we actually are able to do that with a separate CPU that doesn't actually take any performance away from your RAID companion processor. So when you think about this, and we'll talk about it in a minute, but if I take EMC, for example, EMC has a great document that talks about their auto-tiering. Their tiering is automatic, but it's actually called batch. And I got a slide that talks about batch, but I want to talk about this here for another minute. When we talk about batch, is they basically say, we'll move your data once a day. We'll move your data once an hour. But if you look closely at their best practices, they're actually recommending that you do not move stuff into SSD and off from SSD during business hours. Why are they saying that? Because they're actually afraid that the movement will actually cause too much overhead for the processor. And what basically this means is it means that you'll actually lose performance, or you'll have a degradation of performance while this thing happens. And one of the main reasons for that, if we go back to the competitor design, they have one big processor, as big and as powerful as it may be, it's still processing everything. What we do, and what we'll be able to do, is we'll have that separate CPU complex, and that separate CPU complex will be able to handle movement of data, and it's done in parallel on the side. Now, keep going now and show you the rest of it and how the workflow comes in. So cache memory DDR looks the same, back-end I/O, front-end I/O. So everything basically looks the same. We also have a PCI to the other controller, but two things. So if you look at the left-hand side, this pinkish-looking one, we actually have a separate CPU complex that's there, and it's for the software piece of the items that we do. And on the right-hand side, we got the super cap, which basically helps us avoid the use of batteries. And it's also a patent that we hold, and it helps us with that. Now let's look at the pattern of I/O. Now we also have the management. The management runs there. It's just the UI, but I wanted to add that and make sure it's there. So what basically happens? Well, when we have a write command that is received by the host, it actually comes in, touches the RAID companion, goes to the CPU complex, notifies everybody, and then we'll come back and say, you know what, we're ready for you, give me your I/O. So far it's almost the same with the competition. But let's look at the next one. The next one is the most critical one. This is one operation that actually touches your cache memory DDR, and if you look at that, the host comes in and sends its I/O. But when it does that, we have a special, and that goes back to the patent that we're holding, is we have a forking option within the processor. So the processor, as soon as it gets the I/O, it actually forks the I/O in two separate locations. One into the cache memory of its own controller. The other, it actually sends it to the other partner controller's cache. So it basically says, I'm going to send it to my cache, and I'm going to send it to my partner's cache. And that's all done with one transaction. That's pretty significant, again, because it takes less cycles of your CPU, where with the competitor view that I showed you, we actually had two operations that actually had to do that. So you have to come in right at once, then you have to go out right into your partner controller. So you've actually saved, it's basically half of what you've had to carry on your competitor controller. We also call this synchronous caching. There's different terms in it. I think the term that we've decided to use here with Lenovo is called synchronous caching. It basically means as soon as the I/O will come, the processor has the option to fork it, and once it forks it, it sends it in parallel to both of the controllers. Then what we'll have is the CPU on the left-hand side will actually come back to the host and say, hey, Mr. Host, we've written your data, and you're good to go. That's basically a significant improvement. Now, if we look at our super cap, or the power, when power is lost, the only portion of the hardware that needs to maintain active and be powered by the super cap and move the cache around, it's a lot smaller. There's a lot less data that needs to be moved, or a lot less data that needs to be written. Hence, the super cap could be smaller. The super cap does not utilize batteries. By the way, the super cap by itself, I've got a slide on that, doesn't require battery maintenance, and it's got a lot more additional inputs. And we do not need the secondary CPU for the software only to be powered on by that, because it does not hold any of your critical data piece. So it's really important to show. And we also show that we only have a portion of the RAID companion powered on just to make sure that we are able to flush down anything that we had into our cache. RAID controller efficient cache backup, that's basically our super caps. Instead of using batteries, we have a super cap. Service is about a 10-year life. There's no service calls, there's no maintenance, there's no wear cycle. You don't have to make sure of the voltage, the temperatures. It's pretty significant. Not hazardous, and then recharges within minutes versus hours of battery, and then it's pretty simple. It's a part number of the controller's screw. I'm going to take a pause here and ask if there's any questions before we move on to the differences of the physical hardware configuration on the S22 and the S32.
No more questions so far. Oh, wait, one just came up. Hang on. Says, can you speak on the performance difference based on using one large pool of disks assigned to one controller versus splitting all disks into two pools, each pool assigned to a controller?
Yes. I will, with the question submitting person's approval, I would rather pick that up in our best practices. I have a slide that talks about best practice. It's not necessarily related to the two topics that we've had here. It's a great question. I'll address that, but I'd like to keep that to a little bit of a later time if you guys don't mind.
No problem, he says.
Perfect. Thank you. All right. 2200 controller architecture. So let's look at that. We've got, these are some code names that we have, which we call mention use, companion ASICs. We've got a PCI with 4 lanes into the CPU. The CPU is pretty small CPU, by the way. Cache memory is what we got over here. Then the back end and the front end piece. We got the management, which is the ARM. It's basically a small portion, and it runs within the RAID companion. So if you look at the differences, look at this one here. This is 1-core, 800 megahertz. And again, these are not fast-performing CPUs. These are not your big monster CPUs because these only run the software piece. The RAID ASIC companion runs your I/O, and that's why we're able to actually separate these ones between them. Now let's look at the 3200 companion. So this is a 1.3 versus the 800 megahertz. It's faster there. And this one has one PCI with 4 lanes. This one has 2 PCIs with 4 lanes. So it's got that addition increasement as well. 4 gig DDR, 2 times 1200 megahertz. Over here we only have 1 times 1200 megahertz, so you can see the performance increasements over there. And then, hold on a second. Over here we have on the back end side, we only have 1 PCI with 8 links to it. And on the 3200, we actually have 2 PCIs with 8 on each of them. And that's what you see the differences between the 32. And that goes back to the other question that we had. Is it only because we could load more drives? No. This thing it's armed with more. So we have, instead of 1 1200 megahertz, we have 2 of them. Instead of an 800 megahertz, we have a 1.3. And then we have the PCI links themselves, PCIEs, we have more channels and more buses to each one of them. So it gives you that increasement in performance as well. One more thing, does the back end? Yes, back end as well. So front end is 1 by 8 and back end is 1 by 8, where the 3200, if you look at it, we have 2 by 8 on both the front and the back side of that basically means to the hard drives and to the front end of the client side. And we also have PCI. Sorry, just one second. We also have 2 PCIs with 8 links in between the controllers themselves. That means we can transfer the data between the controllers. That usually reduces the latencies as well. And there was a question?
Yeah, the question came in, says they thought the controller had 6 gigs of cache per controller, not 4.
So when we say 4, the 4 is a part of the usable. If you look at the CPU on the left-hand side, you get 2 more gig of RAM. The 4 is the usable for cache. The 2 is used separately for the CPU portion. So we don't use the same cache as the user I/O would. But it is 4 on the controller cache. We say it's 6 because when you look at a competitor's architecture, when they say they have 6 gig or 12 gig or whatever, how many gig they have, they don't tell you how much is it usable, how much it is within the system. Here, this diagram is a little bit deceiving because it shows you specifically that you got 4 gig for the host I/O and you got 2 gig working for the controller itself. So that will be for some operation that we utilize. But it is 6 gig per controller for cache. It's just that the way it's divided within the 4 gig for the host side and then 2 gig for the system side.
He says thank you.
You're welcome. All right, synchronous caching. It talks a little bit about the broadcast write feature. So write data is received from the host and written to cache. And then what we got here is you can see the forking at the same time. So basically we'll come in, as we write it to the partner controller, we'll be able to actually write back, and then the data is read from cache and written back to disk. So you can see the performance increasement that this would give you instead of having to wait for the processor to read it back from cache, send it to the other controller, get an acknowledgement from the other controller, and then only then reply back to the host. It's a pretty significant one, and we're really proud of the way we've done that. Some of the benefits of synchronous caching, performance benefit, it helps you with bandwidth. Controller cache is synchronized using a dedicated high-performance interconnect, and it also allows the entire bandwidth of the backend to interconnect with a dedicated moving of the data. So unlike traditional implementations where they actually have 2 separate operations occurring. Bandwidth of the memory and the bus is used only once within each write, so it's really, really important, so you don't have to use that same bus multiple times for the same amount of data, so it's pretty significant. And of course, latency. The processors are not involved in moving in the mirroring process, and then write latencies are significantly reduced with that. And with all that, it improves the overall traditional implementation. But we say in a minimum of 50%. I've seen it sometimes improve it even better depending on what you're comparing it to. Next, we'll talk about the CNC piece. And the CNC piece is what we talked about, the SFP pluses that you're able to take out and plug in. That's what they basically look like. They actually have their own SKUs, so you can actually order a different SFP plus for your system. You could do that during the original purchase or at a later time as well. This is what an S22 and this is an S32 actually in the picture itself, but that's what they would look like in terms of a physical back side layout. You can see there's a management port right over here. There is this is controller A, this would be controller B. A is always on the top. You got the 2 host ports for the 2200 or a 4 host port like we have here for the 3200 where you can mix and match. You've got some management ports as you can see here as well. You've got them on both of the controllers. And then a serial port for engineering and some L3 and disaster recovery only options. And these over here will actually be your expansion ports for your expansion units, your eBuds, to extend that with additional chassis underneath. SAS, that's what our SAS connectivities would look like. You cannot use hybrid on SAS, so that's a separate physical controller. It's not a swappable one, so the SFP pluses are only for your iSCSI and fiber channel, and then if you choose SAS, it's SAS all the way. These are what the expansion unit looks like, and these are the expansion units, and they're controllers or their piece of expansion. And you can see these are the in ports and these are the out ports. So you can actually daisy chain and continue on chaining more and more devices to it. Customer replacement units, these are really, really important. Everything is common across all of our products. So you can change the controller, you can change power supplies. They're basically swappable, so you could take a chassis of a 2200 and stick in 3200 controllers in there, and you've just upgraded your system from a 2200 to a 3200. Everything is pretty modular and very easy to swap and move forward. Common form factor, as we said, a 2U24 or a 2U12. We also have special trays to allow you to use small form factor SSDs within these 2U12 form factors, large form factors. In-chassis upgrade, so within the product family, we share the same metadata structure, so there's no differences between the metadata. Customer can upgrade from an S22 to an S32 without any data migration. So all you got to do is you shut down gracefully your array, you swap out the 2 controllers, you plug it back in, and then you don't have to reconfigure anything or re-enter anything or save any configuration files. because all the important data of the persistence of the WWPN, the IQNs, and some other items, passwords, and IPs are all kept in the mid-plane, and the data itself and the metadata of the volumes themselves live on the drives in the SEN itself. So there's basically no need to migrate any of the data, and it's pretty significant, and it becomes pretty useful. Before we move into the software deep dive, any more questions?
None so far.
Perfect. All right. A second here. All right. Let's move on to the next slide. So, new entry storage innovation from Lenovo. So if we think about it, data today is growing, and it's also consistently changing. And if we look at that, and what I talked about is along with that, we've got, how we access it. So we want our phones, we want our pad devices, we want our laptops, and it's all really, really important. So if you think about it, what we want to actually be able to do is be able to utilize SSDs with performance HDDs and some capacity HDDs. And what you really want your system to do is you want your system to be workload aware. What does that really mean? And again, I'm going back and I keep on pushing on that. But, I travel a lot for work. I go meet with our sellers, meet with our end users, do all these things. And, I get in my car, and the first thing I want to do is I pick up my mobile device, and I'm looking for direction as soon as I get into the rental car. And I keep saying to myself, do I want to hit that button and wait for a minute until it gets me that data? Can I afford to wait until we get that? And my answer is always no, and I keep saying, why can't we, when we sell these products, why is it so hard to see that migrating your data or making your data workload aware and putting something in SSD when it needs to be there and not an hour later or 7 hours later or a day later? You can't afford to do that. I can't click on my direction and wait for a day until I get directions to where I want to go. These things need to occur live in real time. So I think it's really, really important to mention, and I think it comes best as your workload-aware intelligence on your hybrid flash arrays. So what we've got is we've got a Lenovo SEN Manager. That's the software piece, the UI. We've got the hardware that we've talked about so far. And our main thing is that you'll get your data where you need it, when you need it, and that's real time. You will not have to wait the day, the hour, or the 5 hours, or the 3 hours, or the scheduled period of time to get your data, your hot data from your SSD. So SEN Manager overview, data tiering. Data is automatically moved between the storage layers based on access. Then provisioning, overcommitment, and unmap. We support all of them. It will be optimized and efficient with available space. SSD read caching. So, we talked about how big is the cache in the controller, and we say, wait a minute, why is it only 4 gig? Why is it only 6? We found out that you basically don't need that. The reason you don't need that is if you do want a faster or more equipped controller and you don't want to raise the price for everybody, just take one single SSD, stick it in the array, it's 400 gig, and make that a read cache SSD. Basically what you do with that is you take your controller and you've taken your 6 gig of cache and you've bumped it up from 6 gig to 406 gig. And you've just gained a pretty significant amount of cache for yourself as well. If you want your cache to be not just for reads and you want it to be for reads and for writes, then all you need to do is use SSD tiering, because SSD tiering will give you a significant amount more cache for both reads and writes. And we'll talk about that in a few more minutes. Rapid RAID rebuild, it's really, really critical today. We've got more and more large capacity drives. The drives are becoming larger and larger as we grow our capacity. And it takes quite a long time to rebuild a 72K RPM drives today. So if we take a 10 terabyte 7K drive today, it can take almost 2 days to rebuild a drive like that. What we have done with rapid RAID rebuilds, we're able to minimize the recovery time and the risk factors with rapid data restoration. So basically we know how much of the data is in that drive, and we can accelerate the rebuild of that drive. Basically, if you look at common scenarios, if you've got a failed drive, you got to take the first block all the way to the last block and rebuild all of them within the RAID that you've had. With our solution, we basically know how much of the drive is being utilized. If the drive is 100%, if the drive that failed was 100% utilized, then the rebuild times will not change. They'll still be the same. But if your drives, and the goal here that the system will be balanced, and that we'll talk about in a minute, back to the question of do we want to balance or do we want to keep everything on the same controller. But the more balanced the system is, the less common you'll have one or more drives that are completely full. It should basically be split across. And if you've got a split across drive, meaning only half of the drive is full of capacity, when we have to rebuild it, it will take half of the time because we're data aware or page aware of where the data actually sits. Snapshotting, we provide point-in-time copies of live data, no need to restore, and no need to no performance hit. It's pretty significant as well. Some of the other competitors will tell you if you turn on snapshotting, you'll get some performance decreases. Why? Again, we're talking about the same processor having to deal with everything. With our snapshotting, every volume is a snapshot, or every snapshot is just like a regular volume. And because we can do all these software stack options and a separate CPU, we're able to reduce that performance hit to almost none. So when you create a snapshot and you compare a snapshot to a regular volume performance, there's basically no differences between them. Storage pooling is automatically pull all your data, all your storage together, and then simplify the storage setup. And we'll talk about that in a few more minutes.
Do you have
Management
a question?
UI? Sure.
It actually goes back one more slide back, but it says, when swapping controllers on an S2200, can you just swap one S3200 controller into the 2200 box? If so, can they be hybrid? Example, one S2200 fiber channel and then the swap of one S3200 controller and use iSCSI.
That's a good question, and we've gotten that question a lot from customers who got creative and wanted to do the swap from 22 to 32 live without shutting down the system. The answer to that is no. The reason for that is there's less cache in the S2200, and the busing between the controllers is different between the 32 and the 22. Remember how I showed you that the interconnection between the controllers for the cache mirroring is different between the two. If you bring a system with one S22 and one 2200 controller and one 3200 controller, the system will not come up. It will try to negotiate and identify the links that it has between them for the cache mirroring. It will see that it's not the same, and it will not allow you to bring it up. So you cannot have a 22 and a 32 up together. In terms of the SFPs, if you wanted to have a 22 where the top is fiber and the bottom is fiber channel, you could do that. The only thing you're going to miss out is you're going to be missing out on high availability. So if you have your top iSCSI controller fail, we will move the data. We'll serve the data from the bottom controller, but the bottom controller is connected via fiber, and your host wouldn't be able to get to that. So if this is what you're trying to achieve, just get a hybrid S3200 and have 2 ports fiber, 2 ports iSCSI, and that it's fully highly available, and data could be presented and accessed from either controller at any given time. I hope that helps. That answers that question.
I believe it does.
Thank you.
He says thanks.
All right. Interface. So UI-wise, no Java, no ActiveX. They're all browser-based. It's pretty common today with everybody. Support, Internet Explorer, Chrome, Firefox, all the main ones. Command line interface, Telnet, SSH, or direct connect via USB. And we could also do HTTP scripting for XML content, encoding, and some other things, so if you want to configure multiple things. So the next slide is a very nice one. It basically talks about the traditional RAID architecture, what we've had so far. So today's environment, and I want to say that about 70% of the data centers today that are using SEN are using traditional RAID architecture. And what does it actually do? So if you look at the left-hand side, you've got the disks. So you've got some SSDs, some 10Ks, and some nearline SAS. And when you create LUNs, a LUN that comes from the SSDs is always on the SSDs. Like a LUN that comes from the 10K is always on the 10K. And a LUN that comes in from the nearline is always on the nearline. You cannot mix and match. Now, the reason I like to talk about this a lot is, in my previous life, I was a Solaris system administrator. And then from that point on, I moved on and I became an Oracle DBA. And I'm talking about many, many years ago. But what I remember the most is that when I looked at the databases and when I look at a database today, I could probably say that about 70% of your data is stagnant. It's data that doesn't change, data that was written once and it sits. So what I'm saying is, and back in the days, we used to say, well, I want fast-performing 15K drives or 10K drives for my Oracle database. Why was that? Because some of it needed the performance, but the majority of it didn't. And if you look at the traditional RAID architecture, you're still stuck with the same thing. So if you buy an all-flash array and you give that to a VM environment or an Oracle environment, everything within that volume is got to live there. And you might be, you're 100%, I'm 100% sure that you're underutilizing some of these SSD resources because majority of the data is not hot at the same time. So if you look at an Exchange server, not all the mailboxes from everybody is all accessed at the same time. You have your mailbox and you've got some old data in there, and that data could be sitting on 10K drives or 72K RPM. So why would you want to spend so much money in putting everything in one location? And the old traditional RAID architecture did not allow you to do that. The only option you had is you take some SSDs, you pull them together, you put them in a RAID set, and you present the volume out of it. So it's really, really important to actually talk about these things. Now we're talking about the virtual storage pool. So what do these basically mean? If you look, we've got the SSD gray portion, we've got the green of the 10K drives, and the 72K RPM. If you see them, we actually combine them together into pooling, and we'll create a performance tier, we'll create a standard tier, and we'll create an archive tier. Now on top of the tier, we'll create a pool for each controller, and each controller will be able to access all three tiers. So if you look at this portion over here, you've got the gray, green, blue. It basically means that you've got access. So all of your LUNs at any given time have access to all of your drives, your SSDs, your 10K, your 72K RPMs, all at the same time. And if you created a volume for an Oracle database, for a VMware, or something along these lines for a big project, and some of it is idle and it's not being utilized, it's going to trickle down and spend its life in the 72K RPM because there's no point of keeping it and utilizing a resource that it's not really able to exhaust. And on the other hand, if you have a volume and you've got a small portion of it that's working pretty hard, we'll identify that immediately, we'll transfer that into performance SSD piece, and we'll be able to accommodate that and serve that data from SSD portion. So just a few points. Automated pooling, it simplifies the storage setup. Wide striping increases the capacity and throughput. LUN have access to all of this in the pool at any given time. Virtual storage pools in foundation of Lenovo Stand Manager feature. It's all basic. You can enable large LUNs. Volume sizes are not limited like traditional RAID sets. You can increase, you can reduce the size as well, and it gives you a lot more options to actually do that. Let's look at the disk constructions as we have it today. So RAID groups. On the SSDs, 15K, 10K, or HDDs, 72K RPMs, HDDs as well, and then we could do RAID 0, 1, 5, 6, 10, 50, or 60. These are the SSD portions. Then we have the VDisk that we create. So we'll still actually create a VDisk or a virtual disk group or a RAID set on top of it. But that's an abstraction of each RAID group of an instance. So we'll take each one. But what a system will automatically do is the system will take and divide them per type. So it will take each type, and each type will have its own. So we'll have a VDisk for the SSDs, a VDisk for the HDDs, and a VDisk for the 72K RPM. What this will actually do, will create three different tiers. And these tiers will be your performance tier, your standard tier, and your archive tier. And that's done automatically within the system. And then what happens is when you have your storage pool above it, your storage pool above it will be able to share all the resources from your performance piece, your standard piece, and your archive piece. And if you look at your LUNs on the top of it, you're basically able to present these LUNs to the server, and any given LUN can have some of its portions on SSD, some of its portions on 10K, or some of its portions on 72K RPMs. Now, it's not a must to have all. It's not a must to have either one or another. You could have a system with just SSDs, a system with just 72K RPMs, a system with a mix and match of 10K or 72K RPMs, or a system with SSD and 72K RPMs. We actually see the majority of the industry going to a simplified configuration of SSDs for fast, 10K for archive. So anything that's not going to need immediate attention will go to my 10K large form factor drives with a lot of capacity, and then anything on my left-hand side for my performance one that needs performance will go into my SSDs. And we're seeing the most bang for your buck configurations. You will get the most capacity and less amount of money spent for the best performance you'll be able to get. So that's basically what we're getting. We're an active-active ALUA configuration. It basically means that it's an asymmetric logic unit access, but it is an active-active configuration with a preferred path. Now, before we go to this one, I'm going to take a pause here, ask if there's any questions. I think there aren't.
Nobody's typing any in.
Perfect. So the next two slides, I kind of say are probably the most important ones that I like to show to customers. Why do we do that? We kept talking about the differences, real-time versus non-real-time, Lenovo's real-time data auto-tiering versus batch data migration, and the differences between them within the competitors. So let's look at this slide. This slide talks about batch data migration, how it works, and what it basically does. I like the turtle, by the way, overview. So we've got incoming data. The incoming data will always come into Tier 2. So nothing goes into the SSDs, nothing goes into the Tier 3. It comes in, everything, whether it's hot, it's cold, it's warm, everything lands on my 10K drive. That's your basic configuration within today's environment. Then we've got a timer going, and you got to wait for either an hour or 2 or 24 hours. While that time, nothing happens. Everything is still served from your Tier 2 option. And then after 24 hours, the system will go out, scan, and I know, IBM has got some other options, and it says it could be up to 24 hours depending on how the system works. But in most batch migration, you have no guarantee that real-time or close to real-time, you'll get your hot data served from your SSD. So even though I might have the SSDs, I might have to wait for a day, for an hour, or for half an hour, for 15 minutes. But I still have to wait until my data will actually go there. And that's a big difference in the batch data migration, or the biggest disadvantage that a batch data migration option has. The next slide, we'll talk about Lenovo's intelligent real-time tiering. So if you look at that one, we have a 5-second stopwatch. And when we play this, you'll be able to see the data coming in. As the data comes in, and I'm going to pause it here for a second, as the data comes in, we have a few things that we evaluate. In flight, we're able to see, is it small block size and is it random? If it's small block size and it's random, we don't even have to wait until it lands in the enterprise class HDDs or the 10K drives, and only then move them into the SSDs, and I show that, by the way, in my live demo. We actually move the data directly into the SSD. Versus the competitors where they have larger pages. We move 4 meg in page, and we can move more up and down because of the CPU, which is separate to ours. With their side, because it has an overload on the CPU, they accumulate more capacity. I think the IBM and the EMCs do about 1 gig, where we do 4 meg in page. So moving 1 gig into the SSD and then waiting for 24 hours until we have to move it back is a pretty big penalty. That's why with the competitors, they put everything on the mid-tier, let it sit, and then once a while there's a batch process that wakes up, evaluates, and then decides to move things. As I said, with us, we've got two things that are going for us. The first thing is incoming data. We'll look at it live. If it's small blocks and it's random, we'll automatically send it to the SSD. And if it doesn't need to be on the SSD, it will only take us 5 seconds after to realize that this thing shouldn't be on the SSD and move it somewhere else. The second portion is data that's already within my system. So it came in, it was not hot, and it's sitting in my mid-tier or my archive tier. And then it sits there, and all of a sudden it becomes hot. So somebody came in, there's a new project that comes in, you're trying to pull some stuff from your email, you're trying to pull some stuff from your storage capacity, your drives. All of a sudden it gets more and more hits. As soon as we see that on a 5-second interval, automatically the system will take that and move it directly into the SSD. So even stuff that is on my 72K RPM with my cold data, it can become hot, and it doesn't have to travel between 7K to 10K and then to the SSD. On a 5-second interval, I can take a full page, which is 4 meg in size, and I can do multiple of them, but I can take one page and move it from my cold data into my performance SSD, and all of a sudden, within a 5-second interval, your data is already in your SSD. Pretty significant, pretty powerful. I think this is the one biggest advantage that we have versus the other competitors. Everybody will say we use hybrid. We also do hybrid. They do hybrid. That's true. Everybody will say we do auto tiering. It's true. It's automated, but it's batched with the competitors versus us, where it's automatically, fully automatic, and you gain the functionality on both ups, downs, and new incoming data and data that already exists within your system. Any questions before we move on the batch versus real-time?
I am not showing any.
All right, I hope these are good signs. Thin provision and oversubscription. What is thin? You can create a volume, construct it now, but only allocate the physical capacity when needed. Flexible, optimal use of storage, so you don't have to put anything when you don't need it ahead of time. This is an example. You know, host one, I present a volume that's, I don't know, 10 terabytes, but it doesn't get used. As soon as we start using it, as soon as it fills up, we'll actually create and allocate more and more capacity for it, so we actually get some of that. We also support oversubscription. You can disable it or enable it on a volume level, and you can decide what you want it to do. Thin provisioning on unmapped, so if you delete anything on Windows 2012 revision 2 and upwards and Red Hat 7, actually I think it's 6.1 and 7, and anything that comes after that. We support unmapped, so anything you delete from your volume, the operating system will notify the array will release these pages, and you'll have less capacity on your system as well. Within VMware, it's supported as well, but it's a manual ESX CLI command to actually reclaim these blocks. So you can automate that with a script, but that's how VMware does it today. SSD read cache. We talked about the SSDs used within our array. We could use it for read cache, basically to increase our read performance and to increase our cache with reads only. And, of course, we could always use it with a full tiering capability, but that is an additional license. So read cache, SSD is free in the base license, would only improve your performance in reads. And then SSD tiering is a license, but it will improve your performance on both reads and writes. So SSD read cache basically it serves as an extension of your controller cache, and we talked about this before. Rapid rebuilds, that's what we talked about before. If I've got these 3 drives, I know what's used and I know what's not used. The blocks.
We have a question.
Sure.
The question is it a minimum of 2 SSDs for read caching?
There's no minimum. There's a maximum. It's 1 physical SSD per controller as a max. Most would be 2, 1 per controller. That's for read cache. For read and write, there's no basic limitation. You get to scale as much as we want. We recommend usually 12 SSDs per system with 6 SSDs per controller. That's your max SSDs, but it's not a must. I've had customers who've deployed 24 or 48 SSDs. But read cache, there's no minimum. There's a max. There's a hard restriction. It's just 1 SSD per controller, so 2 SSDs totals.
The comment come back was that the previous slide said minimum.
Might be a typo in it. So it's actually a maximum of 2 SSDs per pool. Actually, so that's a good catch. Thank you very much. I'll make a note for myself to fix this, but it's not a minimum. It's a maximum of 2 SSDs per system, 1 per pool. So excuse me for that typo.
Thank you.
All right. So the rapid rebuild piece, as you can see, these are the drives that we talked about. If the drive has unused blocks and they're not used, we will not have to rebuild them, and that's how we are able to rebuild our drives faster. Virtualized snapshots, all snapshots are support full reads and writes. They basically act like a regular volume. Snapshot is a regular volume. All volumes maintain high performance. Snapshots are standalones or nested. And there's no setup or maintenance or planning or pre-planning that needs to be done. So you don't have to decide, I want to create a snapshot pool, I want to create dedicated space for snapshotting. How much snapshotting will I have? There's basically no need to do that. And you can roll back, of course. You can make changes. And, of course, snapshotting improves your RPOs and RTOs, and they're great recovery tools as well. White striping, you can see traditional LUNs on the top. It shows you that you only had 3 drives and you had 1 LUN on top of them. And you have LUN number 2 with 2 drives, drives 4 and 5, and they're using that one. If I've got a pooled disk group and I've got 2 LUNs, they can all share the entire 5 drives. And with the correct paging mechanism, the correct migration piece, they'll be able to, actually accommodate the best performance out of these drives. Virtual pools, white striping, increased capacity and throughputs. Rebalancing, we could do quick recovery and performance. So we would rebalance items. That's a good point. So in my live demo, when I show this, I show myself adding 2 SSDs. When I add the 2 SSDs, I can add 2 more SSDs afterwards as well. I can add any additional drives as well. So you can choose to start your system without SSDs and add them later. You can choose to add, start with 2 SSDs and then add 2 more later. We have a unique rebalancing item that, again, the CPU, which is a separate component, uses. And while the system is relatively idle, we'll take the data from the pool that's got, or from the drives that are almost full, and we'll rebalance them into the new devices that were added. So if you've added new drives, you'll be able to pour in these devices. So if I had, for instance, if I go back into here, and I have, let's say I have, on the top, I have 3 drives, and then I go out and buy 2 more drives and add them into them, or create another tier, another pool, or another disk group. When I do that, I'll be able to take whatever is over here and spill it over to the next ones that were just added, the next drives that were just added. Doing that, it allows me to better balance the load. It allows me to both reads and writes, old and new performance improvements. And if I do need to rebuild, it's better to be able to rebuild a half-full drive or a not fully full drive and be able to utilize the entire drive that's spanning across the entire pool versus if I don't rebalance, I might have 2 drives that are 100% capacity and then 2 additional drives that are 0 or 10% capacity. So we've got that option as well. And then large ones, 128 terabytes, these are all testing limitations. There's basically no real limitation that needs to be there, but these are for testing purposes, 120 terabytes. I think there's talks about moving it to 256 as well. Licensing, it's a really important slide. So HDD tiering, S2200 and S3200, it's free and it's in the base license. Then provisioning, base license. Rapid rebuild, base license. SSD read cache, base license. Virtual snapshots, there's a base license 64 and 128 between the 22 and the 32. And then you've got the SSD tiering, which is an optional license on both systems. Any questions so far? So I'm going to do a time check. All right, I'm going to do a time check. I'm going to zip through some of these because I want to get to the best practices, and I have a commitment to answer the question that we had on the preference of how to split the information on the systems themselves. But a few more points. Encryption, SCD, we'll be able to utilize SCD drives. We now have SSD with SCD as well, so if you want to encrypt the drives, we fully support that. These are some use cases. If you still the drives or still the array or change some things to it, you wouldn't be able to do anything with it. SMIS, so we do support SMIS. SNMP, so you could actually support the protocols, both 2 and 3 for monitoring. You could also support traps, notification, so we do support that. And we can notify to a Lenovo MIB that's supported there. HTTP API, similar as to REST API, URL, CLI commands, XML. We can completely configure array if we wanted to as well, and we utilize scripting and automation with curl, wget, Python, and some other things as well, PowerShell and some others. I'm going to go on to the next screen, and the next screen will show us some screenshots. So this is the UI, what the UI would look like. This is what the login screen looks like. This is the Lenovo Storage Management Console, username and password. This is what the UI would look like. This is something we call a dashboard, or the main dashboard. You can see it's the home screen over here. And then what we've got a system here is you've got pool A that has SSDs with the red, 10K drives with the green, and some 72K RPMs with the blue. And on the right-hand side, I only have SSDs and 10K, or I could have SSDs and 72K RPMs. Or I could have a system that storage pool A has SSD and 10K, and then on storage pool B, I only have 72K RPMs. Because I know for a fact that I'm going to put my important data or my VM or Oracle and Exchange on my storage pool A. That's where I'll create the volumes from. And on storage pool B, I could just put my FTP data, my home shares, and some other backup volumes as well. So that goes back to the question that we had, and I'm little by little answering that, and we'll go back to that and make sure I've answered all of it. But the 2 pools do not have to be identically configured. We do strongly recommend that the 2 pools will be used because pool A utilizes controller A and pool B utilizes controller B. And if you're only utilizing controller A and controller B is sitting idle, you're not utilizing its CPU, you're not utilizing its cache, you're not utilizing its physical host ports, so you're not basically utilizing the system to its max. Can you do that? 100% true. The system does not limit you as to how you configure it. You can decide what you want to configure. We would still recommend to configure. I do see more and more customer not configuring pool A and B identical. What it basically means is they have a preferred pool, which sometimes is pool A, where it might have 2 SSDs and 72K RPMs, and then pool B is only 72K RPMs large form factor. And they segregate where the volumes that are going for the VMs, the Oracle, the Exchange, and so on are coming from controller A, from pool A where it's got the SSD and the auto tiering, and then pool B only has 72K RPMs, and it's only for your backup, your FTP, your home shares, and so on and so forth. That's basically what it would look like. Some additional items, we got the host ports on the top. You got the ports that you have. This is a 3200. You can see that it's got fiber channel ports across them. There's some additional information in it of what you could do. There's your alerts. There's a check mark here that says the system is in good health. If you had any spurs, that's what the spurs would look like. If you had IOPS going in or throughput going in, you'd be able to see that over there. You can see some great statistics from your main page, the total capacity that you're using and so on. In the action pass, you could change the base of the selected page, and you could start configuration with it and do some other things with it. The next tab is the System tab, and it shows you the front view of the system. That's what this tab, and you could go to the rear tab and actually see the rear view as well. It's not a live view, but it is a true view, meaning it actually shows you what your system looks like. So it is a picture, but it's a true picture. It's a picture that actually describes and shows what your system really looks like. You could also see that you've got some greens here. These greens are your 10K drives. You've got some reds, which are your SSDs, and you've got some nearline SAS, which are your 72K RPM. So it gives you a good overview of that. You can export that. You go into the table portion. You can export that and do some more actions to it.
We have a question.
Sure.
The question is there a best practices guide?
So we do have a few floating, meaning if you go to the Lenovo correct resources pages, you'll be able to find best practices for configuration, best practice for volumes, best practice for maybe VMware, best practices for SSD tiering. So there are some good documents out there. There isn't a single one, but there's quite a few out there that will help you to do that. And then, of course, if there's anything you need that you want to create it, or you believe you have a case that you think many more can benefit from it, please let us know. Through Kevin. Kevin will notify me, and we'll make sure you get the right documentation in place. But there are some really good ones out there that talk about best practices and recommended configurations. What we'll do next is we'll talk about the host port side. That's what the host tab looks like, and that's how you create a new host. The system will automatically discover IQNs or fiber channels that are attached to the system. These are my pools. That's where you create the pools. You can create or manage your pools. The system automatically creates the pool, so you do not have to create a pool. You also do not have to create a tier. All you got to do is select drives, create a RAID set out of them, RAID 1, RAID 5, RAID 6. Well, I'll talk about the recommendation in a minute. And then the system will automatically take that and pull it in together. So all the SSD will be pulled into an SSD tier or a performance tier, 10K to a standard tier, 72K RPMs will go to an archive tier, and automatically everything that's under pool A or controller A will be a part of pool A. Anything that's a part of pool B will go into pool B. That's basically how the system will do that. So it's pretty easy to configure and maintain. Volumes tab, this is how you create a volume, modify a volume, create snapshots, delete snapshots, create schedules, and so on and so forth. You can create host groups, you could create volume groups, you could do all those things together. This is where you would map the volumes into your clients. And last but not least, in the UI side, that's a picture that helps me so much. That's a screen that I use a lot. I think we've done a great work on our performance monitoring. You could get so much data, and the system will show you live data and close to 90 days back. And it would show you how is the drive performance, what each volume is demanding, what each volume is getting, what each host port is recommending. and you'd be able to see how your system is behaving, how many pages you've moved up from 72K RPMs to your SSDs, how many pages you move down from your SSD, what gets cold, what gets hot. It's an amazing UI tool. I use it a ton. It also helps me, after the system is deployed, see if I need to add 2 SSDs, 4 SSDs, 10 SSDs. It helps me see and gather a lot of information. This is an area where we're missing some case studies or best practices, meaning we don't have a lot explaining on the performance one. It's something that we're working on gathering. But if anybody has any questions along these ones, you know how to reach Kevin, and Kevin can always get a hold of me as well, and we should be able to help. But this is a great tool that shows a lot of information on your performance monitor. I'm going to skip the targeted workloads. We only have 9 more minutes. Kevin, I'm going to ask you if you have any questions. I'm going to zip through these just view-wise. But you can see that we've got some general purposes, small offices, remote branches, backup appliances. We've got the 3200 for higher data center, higher IOPS. We'll have something, as I said, coming at the end of the year, which will be even more IOPS for even bigger data centers if we wanted, so we could accommodate that. I'm going to skip through these. These are
question came up.
Sure.
Going back to read caching, I have a Lenovo presentation that says maximum 2 SSDs per special purpose disk group. Just want to make sure I understand max read caching SSDs per pool / system. What is a special purpose disk pool?
So it's not a special purpose disk pool. The SSD read cache is really not a part of your pool because it's read cache only. The system will disable or will enable you to add a single SSD only per controller. So it's like a designated controller cache extension. It's 1 SSD per controller. If we have anything else, so there was a time where we were able to add more. We were saying minimum 2, maximum 6. We were playing around with it. We found out that there's no need to add more than 400 gig for recache. So we've decided to limit that, limit the configuration. It's 1 SSD per controller, and that's the way it's limited today.
He says thank you.
You're welcome. All right. So recommendation. So I've got 2 more slides here that I'm going to wrap up. We're going to go back to the person who asked the question on how to split the load. I think I've answered most of it, but if after what we've said and after these 2 slides we haven't yet, then we'll try to attack that again. So drive setup recommendation. We recommend a power of 2 drive setup as it divides better the LBA space for an easier output. What basically this means is, for example, in a RAID 6, we want to have 4 plus 2, which is basically 4 data drives and 2 parity drives. If we have a RAID 5, we will do a 4 plus 1. The reason we do that is a non-power of 2 drive setup requires more processing overhead. So we got to go out, and when we write the data, we might have to write some of the data on some of the drives, and we got to go back and calculate and write the rest over there, and it doesn't align well. Does the system enforce that? No. Can you create a RAID 6 with 5 plus 2 or 8 plus 2 or 10 plus 2? Yes. What we recommend still, and there is a document that talks about that, is for RAID 6, either a 4 plus 2 or an 8 plus 2, or a RAID 5, a 4 plus 1 or a RAID plus 1, or an 8 plus 1. That's what we would recommend. We recommend more disks groups with fewer drives. So 2 4 plus 2s versus 1 8 plus 2 will outperform a single 8 plus 2. Does the system enforce that? No. Why do we recommend it? Because it will get you better performance. So, for example, 32 drives of 8 groups of 4 drives is better than 4 groups of 8 drives. It's common, it's there. We have more pipes going into each one of these threads within the pool, so it will get you a little bit better performance. The system does not restrict you to do that, but this is how we recommend you set it up, because you'll get the most out of your drives and the most out of your system if you do that.
We have a question.
Sure.
Competitively, what's the competitive advantage of the 22 and 3200 over HP's MSA?
So with the new MSAs, there isn't much. It's the same product. Those of you that know Seagate and OEMs this product to Lenovo and HP. So hardware-wise, it's the exact same product. Software-wise, Lenovo gives you more configuration option and gives you more base license than what HP does. So when I've gone head-to-head with an HP solution, we either can beat it on price or get more base stuff in the base license, or get the more SSD configuration. One of the biggest things that we've added with the Lenovo configuration is the 3 drive writes per day. So if a customer wants to buy an MSA configuration today and he buys an SSD, he's buying a 10 drive write per day, about $2,500 SSD per SSD. With the Lenovo option, Lenovo is certified 3 drive writes per day. They'll certify it and warranty it for the same amount of time, because of the way we utilize things. So there are some software, price, and functionality advantages, but in terms of the hardware, it's the exact same product. We recommend disk groups to be balanced. For example, 2 groups of 4 drives each is better than 1 group of 3 drives. That's the disk groups piece, meaning it would be better to create the same one. Again, it's a recommendation. It's not a must. That goes back again to the question that we had. Can we create them separately? Yes. Can the system still be extracted the most performance out of a non-balanced pools? Yes. If the case serves that, then it's a good case, a good argument to do that. But we will still argue that it would be ideal if we could, if they will be completely spread across between the controllers, between the pools, between the RAID groups, and it will be identical. But in real case scenario, it doesn't always happen, and we understand it. And there's some really good cases where you don't need that. So you could save the money. If you know for a fact that you can't afford SSDs and you can only afford 2, buy 2, stick them in pool A, do SSD and 72K RPMs on A, do 72K RPMs on B only, and you've gone that way. So it doesn't follow that recommendation, but it's still very sufficient, and you'll still be able to extract what you want to extract and still be able to save the money that you wanted to save and get a customer with 20x performance on whether he couldn't have afforded to have 4 SSDs. So it is something out there. We also recommend the same criteria for RAID choices. So write-intensive workloads are best served from RAID. This is another typo. This one says here 10. We've actually changed our recommendation to go to RAID 1. So we would recommend our SSDs to be RAID 1 versus RAID 10. There's a reason behind it. In terms of physical drives and the amount of drives that you lose, it's the same thing. But we have a feature that's called auto-draining. And basically, we will drain stuff off when you have a failed drive. If you have a RAID 10 and you have 4 drives in it and you only have 1 drive that failed, the entire rest 3 drives, so the rest of the 3 drives that are available, will not get any new writes into them. So all of a sudden, new writes, if they need performance, will not be able to go to SSDs. That's why if you create RAID 1, they're not a part of the same RAID group. And if 1 drive out of the 4 fails, then itself and its partner will not get new I/O, but the other RAID 1 that's next to it will be able to accommodate SSD. So this is another typo. Kevin, I'll fix these 2 and have it sent to you so you can share it again. But it's we recommend RAID 1 for the workloads for the SSDs, and then capacity optimized RAID 5 or 6. And the last slide talks about the recommendation on tiering. So 1 pool per controller, that's mandatory. 1, 2, or 3 drive types per pool. SSD performance 10K and 72K RPMs for archive. Try to keep the 2 pools, 1 on each controller, balanced with drives tier. Again, it's a recommendation. It's a try. Don't have to, and I understand that there's a lot of cases where you don't. And then the last but not least, RAID types. This is, again, it's not RAID 10. It's supposed to be RAID 1. It's a typo. So RAID 1 for SSDs, RAID 5 for 10K, RAID 6 for 72K RPM. It's not mandatory. If you want to choose something else, I've got customers doing RAID 5 for SSDs as well. Keep the RAID level the same within the same tier. So don't create a RAID 5 for your 10K and then add a few more drives and create them as RAID 6, because you'll be bounded to the lowest common denominator. Don't forget to assign a global spare. And again, use 4+1 and 8+1 for RAID 5, 4+2 and 8+2 for RAID 6. With that, I'll probably say that we'll sum it up. We got about a minute. I hope I answered the question about the balancing. Kevin, see if the user has that question again, or if it's answered.
I haven't seen any more questions come up. I'm trying to scroll backwards here and see where that was at. Oh, that was way back there. All right. Anybody have any more questions? Don't see any coming up.
All right. Well, I hope this was useful. Kevin,
It was.
Guys, let me know, and I will make some modifications and send it your way.
Okay.
You'll be able to make the change on the share that you, the Gmail drive, the G drive that you use. And it's going to make these typo changes.
Okay. I will get those updated and everything out, and I will post the recording on the shared site when this is over. We've got people saying thank you, great presentation. I've had several comments through this about they were wanting the actual deck because the PDF format that I posted up there did not do it justice when you try to look at it. So thank you very much, and if there are no other questions, let's let it go.
Thanks very much, everybody. Thank you, Kevin.